them, they just pull them out and replace them. If they fail, it's easier just to take them out and replace them. Everybody got a picture that wanted it? Sure. Okay. Ignition troubleshooting. And igniters, they work just like spark plugs, just to let you know. So they have an all-weather end, they have an electrode end. They do the same thing a spark plug does, just for a turbine engine. Okay, so under normal conditions, so when you're troubleshooting this or you want to make sure the igniters are working, usually you're going to put your ear by the tailpipe. Somebody's going to turn on the switch, not while the engine is running, obviously, but you're going to hear it pop, 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 pop. If you don't hear pop, 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 then we're going to troubleshoot. I'm going to run this out there as a demo for you guys to show you how it works, and basically a little bit of a safety thing, because I don't want you to touch the sparky thing, because these sparky things will knock you on your...
Keister?
Yeah, or could kill you.
Oh, kill
Depending on how much. So please don't touch them. That's all I ask.
Yeah.
And don't zap your partners, please.
YOLO.
YOLO.
Please don't zap your partners.
Brilliant.
The only thing worse than dying by your own stupidity is by dying somebody else's stupidity. And I don't think if your partner survived is going to be very happy with you. Okay, so if you don't hear the pop, pop, pop noise, there's a few things you can check. First one is the circuit breaker closed? Usually when people are working on the system, they'll pull that circuit breaker so it won't fire or make any, or basically go off by accident. So the first thing you're going to check is to make sure that that's closed. Also that the switch is selected to on. These are simple things that you're going to be troubleshooting, but you don't know how many times that you're like, why isn't it working? Well, the switch isn't on. I know it sounds kind of dumb, but it's not if it's not working. Also, from there, you're going to make sure you have power delivered to the exciter. Check for aircraft voltage at the power plug to the exciter. So, you can't check these exciter boxes, but you can make sure that you're getting power to that box. So, you're going to disconnect the cable, which is right here. On this one happens to be right here. You're going to disconnect it and make sure you have power there. So, if you have power there, you know you have power going into the box. This is basically trying to eliminate everything but the box. Because if there's something wrong with the box, we're just going to remove and replace it, right? So, is the exciter grounded? So you want to make sure you have good grounds. You're going to remove and check the igniter plug. You're going to look for continuity and general condition of the igniter. So basically, you're going to check everything before the exciter box and after the exciter box that it is working. And if everything is good, then you're going to deem that it's the exciter box and you're just going to take it out and put a new one in. Everybody got that down?
Yes.
Okay, so the leads on these, most of the time are okay. So usually you guys check when we were checking the harnesses for the reciprocating engines, we saw there was a lot of wear in these things. But for turbines, the leads usually are fine unless you see a big, huge, obvious damage. Most of the time it's going to be the exciter box or something else, but the leads usually are good. And then the functional check of the exciter obviously will be done at a certified repair station. Everybody got that down? Yeah? I seem tired tonight. Okay, so we're also going to talk a little bit about safety and when you're servicing the ignition system. So when you're working on it, the first thing you want to make sure is that circuit breaker is pulled or off. Also, when you guys are servicing these, you want to make sure that the engine has been turned off for at least 20 minutes to get the voltage and everything to bleed down in the system before messing with it. Yeah, it needs to, yeah, because it's going to be bleeding off into those lines, into those leads. So you want to make sure it's completely all bled off before you play with it. 20 minutes is a rough estimate. I might wait longer, personally. Does everybody have that down? Okay. So never reset a circuit breaker that has lockout or tagout installed and self-flare to do so. So usually they have little lockouts or tagouts installed on the circuit breakers, so you know that they're pulled for a reason. This is just one type right here. I will pass it around, but all you do is you squeeze it. It won't work unless the circuit breaker is pulled. You just pull it out, and then you put the locking mechanism on it, and it will. It's supposed to work here. I hate this one. There we go. And it'll lock into place. I'll pass this around so you guys can take a look. So you might see something like this in the cockpit. If you do, make sure that you go ask everybody if they're done working on the system so you can push the circuit breaker back in. if you don't get clearance from everybody, you need to leave it on there. That's the reason it's on there is because somebody's working in that area and for safety reasons. So I'm going to pass this around, and just like it says at the bottom, high voltage ignition systems can kill very easily. Look at that. That's just one form of a lockout. There's plenty of other ones out there, but that one I see quite a bit. Some of them have tags on them. They'll be on the circuit breaker, so it tells you do not remove and so forth.
What's the never?
The never is just to reiterate this never. He just wants to put it in red and make sure you guys remember to never reset the circuit breaker. It's important, so you remember that. Okay, does everybody have that down? Oh, that's it. So just another picture. So I have a 10-minute video for you guys. VHS, by the way, very nice.
State of the art.
Yeah, state of the art. I've never used this, so I had to come in early and make sure it was working because
Betamax.
it's better than the projector. So before I do that, I will go through this a little bit more. Just so you guys know, when we go out, I'm going to do a demo on how to turn this on so you guys can make sure it's working. During your guys' project, it also says here, do not disassemble anything on this board. Even though it says it there, some people still want to disassemble the things on the board. Please do not disassemble anything on the board. I will say that again. Please do not disassemble anything on the board. So for your project, I want you guys to obviously get it to work, which is really easy. We have those power supplies out there, and I'm going to give you a demo on it. It's very simple. Plug the negative, negative, positive, positive, and you give it voltage and current, and it will spark. For your project, I want you guys to draw me a paper of how the electricity flows through this system. So we just went over how it goes. It's very easy. It goes from the switches into the power, all the way into the exciter box, out to the leads, and into the igniter. The igniters. That's all I want you guys to do. You might want to look up some things on servicing these. And I had some guys actually look up this box and see if they could see the schematic of how this is inside. Some people found it, some people didn't. I'm not asking you to do that, but if you want to, if you have more time, if you're curious, it's totally fine with me. But I just want you guys to tell me how it flows in here, and I want you guys to get it to work, and kind of some of the things that you're going to look for when you're servicing these. Okay? Pretty simple project. Just don't touch the sparky things. And don't let your partner touch the sparky things. Even if they want to touch the sparky things, please tell them don't. Okay? Also, let me get one of the igniters from the back here. A little bit, and I'll show you guys the video. We'll do a demo, and you guys can go to lab. Pretty simple. So like I said, we're not going to clean these. This one's pretty big. They're all different lengths and sizes due to the application of the engine. Just like on a reciprocating engine, they might have longer plugs, shorter plugs, depending on what it's screwing into. Same thing with these. They work exactly like a spark plug. They're just for turbines. Most of them will have more voltage going through them than the spark plugs, but not all the time, depending on the size of the engine. Okay? They work the same way. They have a center electrode. They don't have the two on the out. Remember when we went through all the different electrodes? These ones usually only have a center, and the outside is all grounded. That's the only difference. But mostly all you guys are going to focus on is that you don't clean these. When they hit a certain lifetime, they just replace them. So we're not going to clean these. But if you see different sizes, lengths, that's the reason why. The same thing with spark plugs. Does everybody feel okay with that? There's not much to them, especially when it comes to this class. When you guys go into turbines, you guys will talk about them more. And then the exciter boxes, I think, are talked about also in fire protection. I did when I taught it, but I don't know about the guy who teaches it now. But like I said, most all your questions about turbines will be answered in the turbines class. Okay? Everybody good? It was all quiet? Okay. Let's get your guys' VHS going here. Everybody excited? It's been a long time since I've seen a VHS. Besides this one, obviously.
This program details the removal and installation of the CFM56 ignition system. Both Type 4 and Type 3 will be described. Before disassembly, ensure the system has been deactivated for at least 5 minutes. Remove the cooling shroud clamp and the cooling shroud. Once the cooling shroud has been removed, the ignition lead igniter plug interface will be exposed. Then loosen the ignition lead coupling nut and completely disengage it from the igniter plug. Next, gently remove the ignition lead from the plug. Be careful not to bend or kink the lead excessively during removal, as this could damage the ignition lead or plug. Then, with the lead completely disengaged from the igniter plug, unseat the igniter plug from a Type 4 adapter bushing. Do not remove the Type 4 adapter bushing. It should remain lock-wired and secured to the combustion case. The Type 4 adapter bushing is only removed if the igniter plug cannot be unseated from the bushing. The original adapter bushing, along with the equivalent shims between the bushing and the combustion case, should be used, or igniter immersion depth will be affected. Ensure that the gasket between the igniter plug and adapter bushing came off with the plug. Proper installation of the igniter plug is very important. Since it is a wear-out item, it is the most often changed ignition system component. This system can be assembled many different ways. However, only one, described later in this program, is correct and ensures proper operation. Before beginning installation, have all of the needed hardware and consumables available. An igniter plug with captive gasket installed, a new chamfered silicone seal, and anti-seize grease. Be sure that hands, hardware, and tools are free from any dirt, etc. The conditions under which the ignition system operates makes it extremely sensitive to any type of contamination. First, remove the chamfered silicone seal from the ignition lead insulator, and be sure that the seal load spring remains in place on the lead. Then install the new chamfered silicone seal on the ignition lead insulator. Verify the proper orientation of the seal load spring and the seal. Note, be sure to install the chamfered silicone seal before applying any anti-seize grease to ensure cleanliness of the seal and igniter terminal well area. Next, coat the threads of the igniter plug that mate with the Type 4 adapter bushing with anti-seize grease. Then thread the igniter plug by hand into the bushing until snug. Torque the igniter plug to the torque value specified in the maintenance manual. Anti-seize grease is not used at the lead plug interface because of the threat of contamination to the Type 4 termination. Gently install the ignition lead into the igniter plug. Thread the ignition lead coupling nut onto the plug by hand until snug. Then, torque the lead coupling nut to the torque value specified in the maintenance manual. Finally, install the cooling shroud and clamp into place. For the removal of the Type 3 igniter plug, first cut the lock wire from the ignition lead coupling nut to the adjacent fuel nozzle. Unseat the ignition lead coupling nut from the combustion case and remove it completely. Gently remove the lead plug combination from the combustion case. Be careful that the plug does not fall out of the ignition lead. The igniter plug is held in place by the friction force between the pin and socket connection. In the event of a plug or lead malfunction, removal of the igniter plug may be difficult. Further troubleshooting may be necessary. Install the Type 3 igniter plug into the ignition lead and carefully coat the threads of the ignition lead liberally with anti-seize grease. Then install the ignition lead coupling nut into the combustion case and torque to the value specified in the maintenance manual. Then safety wire the coupling nut to the adjacent fuel nozzle. For Type 4, remove the cooling shroud clamp and shroud from the igniter plug ignition lead junction. Then remove the coupling nuts on the exciter end of the lead and on the igniter plug end of the lead. Open all of the brackets holding the lead in place. Loosen and remove the bolts holding the cooling air pickup junction plate. Then carefully pull the ignition lead through the fan frame. The ignition lead can then be removed from all of the other brackets and removed from the engine. When installing the Type 3 or Type 4 ignition leads, first make sure all brackets are in place and in good condition. Then insert the exciter end of the ignition lead through the fan frame strut and carefully feed the lead through the strut until the air adapter seats. Then tighten the clamps. Next, install the bolt and retaining plate that hold the air adapter in place on the number 3 fan frame strut. Run the lead in the proper clamps as specified in the maintenance manual. Next, gently slip the exciter end of the lead into the exciter connector and torque the coupling nut to the value specified in the maintenance manual. On the Type 4 ignition lead at the igniter plug end, replace the chamfered silicone seal. Verify proper orientation of the seal load spring and seal before installing the lead to the plug. Slide the cooling shroud clamp onto the ignition lead. Note, do not apply anti-seize grease to the plug lead interface threads. Next, gently slide the igniter plug end of the lead into the plug. Thread the ignition lead coupling nut onto the plug by hand until snug. Next, torque the lead coupling nut to the torque value specified in the maintenance manual. Then slide the clamp down over the lead and install the cooling shroud. Then tighten the clamp. On the Type 3 ignition lead, the plug is inserted into the lead. Then anti-seize grease is applied to the ignition lead threads. The lead coupling nut should be torqued to the value specified in the maintenance manual. For either Type 3 or Type 4, slide the lead in the mounting brackets until optimum clearance from the engine hardware is obtained. Note, the left-hand lead has in the past had problems with chafing on the 2 o'clock VSV actuator bell crank. Verify that this area is not chafing. Once optimum clearance between the lead and other engine hardware is obtained, torque the ignition lead brackets to the value specified in the maintenance manual. Both low energy and high energy exciters are installed and removed from the engine in the same manner. Disconnect the power supply cable from the connector, which is on the forward side of the exciter. Place a protective cap on both the cable and the connector. Then, disconnect the ignition lead from the connector on the aft side of the exciter and cap the lead and the connector. Hold the stud in the resilient mount with an open-ended wrench on the stud flat so as to prevent the stud from turning. After removing the nuts and washers that secure the exciter to the bracket, remove the exciter. To install the exciter, make sure the circuit breaker is open. Lightly coat the mounting bracket stud with graphite grease and place the exciter on the studs. Secure the studs with bolts and washers using an open-ended flat wrench to keep the stud from turning. Connect the ignition lead to the connector on the aft side of the exciter and tighten. Make sure that the ground strap is connected. Connect the power supply to the connector on the forward side of the exciter and tighten. Close the circuit breaker. This concludes the removal and installation of the components of the ignition system. For more specific information, refer to the appropriate maintenance manual.
Is that exciting?
Yeah, in the 80s, sure had some sweet bass and such. Like,
Brenda, when you're working on a turbine engine, is it really that cold? When it's in for service and maintenance?
It depends on what you're looking at. Most of the stuff is done on the line. It's not done inside.
It was so neat.
Well, and it's also a video too, so they're trying to show you as clean as possible. Depends on which section of the turbine you're looking at. And then when you go into turbines class, you'll take a look because you'll disassemble the whole Allison 250, which is the little guys out there, and you'll see which parts are which. Because I mean, the burner section is obviously going to have is worn. It's going to have burn marks and stuff like that, depending. But most of the stuff looks pretty. A couple guys in turbines didn't look that bad, did it? No, they look pretty good, right? They've been ran. They're pretty clean. Yeah.
It's not a greasy reciprocating engine.
No, because mostly it's just air going through most sections. Okay, so just to reiterate before we go do the demo on the box, because that's going to take like 5 seconds. Test next week. It's going to be covering everything since the beginning of class until now. And then after that, you guys have a week off for Thanksgiving, right? Cool. So test next week. And like I said, if you want to turn in your written assignments early, you can do that. Like I said, it will help me get your grade to you quicker if you have them in earlier, but they are not due to the last class period. So if you want to turn them all in at the last class period, you are more than welcome to do that. But if you want to turn them in early, I'm willing to take them and I will grade them and give them back to you. I've already done that with somebody else's papers. Okay? So I will give you guys a quick demo on how to set up the power supply with this.